This video will get you ready to start writing the next program called Amicable Numbers. So I'm just going to read through this, show you what a working program looks like, give you a couple hints for your hierarchy chart, and then we can go on from there. Okay, so amicable numbers. Amicable means nice. And if you look over here, we've got a couple of nice, happy little numbers, 220 and 284. They're nice, they're friendly, they're giving each other a high five. So in math, what does amicable number pairs actually mean? Two numbers are said to be amicable if they satisfy the following property. The sum of the proper factors of the first number equals the second number, and the sum of the proper factors of the second number equals the first number. Okay, so we're going to use 220 and 284 for examples. These two numbers are amicable. So when you look at all the factors of 220, this is what you get. These are all the integers that divide evenly into 220. Same with 284. These are all the integers that divide evenly into 284. The proper factors of a number are all the factors of a number excluding the number itself. So if you see the word proper in front of the factors, you don't want the actual number. Every number divides itself evenly. So proper factors of 220 and 284 are the same lists as the ones above, except I took off those values. Okay, so to determine if two numbers are amicable, we want to find the sum of the proper factors of the first one. So I add all these values up right here, and I get 284. And the sum of the proper factors of 284, if I add all these numbers up right here, I get 220. So it's not if their sums of the proper factors are equal. Two numbers are amicable if the sum of the proper factors of the first one equals the second number, and the sum of the proper factors of the second number equals the first number. So essentially I'm checking, does sum 1 equal num 2, and does sum 2 equal num 1? And that's what this says right here. Since the sum of the proper factors of 220 is 284, the other number, and vice versa, 220 and 284 are amicable. Okay, so that's what it means. Here's what the program's supposed to do. Your task is to design a hierarchy chart and write a program that will determine if two given numbers are amicable. The program should do the following. Ask the user for two numbers. So that's just a couple system.out.prints and some in.nextIn. So you'll need that system.in line up at the top. So this is essentially a getInfo method. Determine the proper factors and the sum of the proper factors of each number. Use an accumulator. So we spent 2 days on accumulators. If I have two variables like sum1 and sum2, every time I find a factor of the first number, I can add it onto sum1 using that plus equals thing. And then same thing, I can go through all the numbers for the second number, do a plus equals every time I find a factor, and by the end of all that, I should have the two sums. Now we want to display the factors, the sums, and a message indicating if the two numbers are amicable or not. Run continuously until the user chooses to end it. Use a while loop. So you're going to have an again method in this one again, like you had in cash register. Do you want to run again? Enter 1 for yes, enter 2 for no, something like that. Okay, so I would look at your cash register program when you're doing the hierarchy chart just for the run setup, because the run setup is going to be kind of similar. You're obviously going to write the heading, then you'll have that while loop, while again equals yes or 1, whatever you means 1. You're going to get info, determine proper factors, display sums, and amicable. So this part, displaying the sums and a message if the two are amicable, I hope should be pretty easy for you. Once you've calculated the sums, it's just a system.out.print to get them to display. And to determine if they're amicable, it's what we just talked about up here. If the first sum equals the second number, and the other way around is true also, the second number sum equals the first number, then you can print amicable, otherwise you would print not amicable. So you should know how to do a quick little statement to do that. The tricky part that I want to zero in on for a second is this right here, display the factors. You can't do a display info at the very end and display out all the factors because you're not going to save every variable in a factor, and you can't, because depending on what numbers I give you, you don't know how many variables you need to hold all the factors. So essentially what you have to do is you have to display the variables up when you're determining them. So I don't really want to give it away, but how would you tell if one number is a factor of the other? In other words, how would you tell if one number divides evenly into a given number? Okay, I don't want to say the word, but hopefully you know how you could check if there's no remainder when you divide a number by something. If I have a number like 20, let's say 20 is num1, and I want to get all the factors. What you should be thinking in your head is 1 a factor? Yes, because 20 divided by 1 has no remainder. Is 2 a factor? Yes. So 20 divided by 2 has no remainder. As soon as I find a number that doesn't have a remainder, I want to do two things. First, I want to print it, like I'd print out 1. And second, I want to accumulate that onto some 1. So I would do the same as 2, yes, so print 2, accumulate 2. Is 3? No, because the remainder when you divide by 3 isn't 0. So don't do anything. Is 4? Yes. So print 4, accumulate 4. And we're going to do that all the way up to, we don't want to check 20, so technically all the way up to 19, which obviously isn't a factor, so that one's not going to print out either. But think about what you can have that would start at 1, go all the way up to a number 1 less than the one I'm looking for, and at each time check, is that number evenly divisible by the number I'm looking at? If it is, print it and accumulate it. Okay? So for your hierarchy chart, I need to see your run method, and I kind of talked you through that. Show me the while loop, the get info, determine factors, that kind of stuff. Get info, just tell me what info you're asking the user for. It's determine proper factor and displaying the sums in a message that I really need to see written out. So write some detail with those methods in your hierarchy chart so I can see that you know what you're doing. Okay, so when you got your hierarchy chart done, or if you get stuck, come have me check the hierarchy chart, or I can give you some more pointers. When you're ready to start typing the program, if you flip your paper over, you should see this. Test your program with the following amicable pairs. So I need to type in all of these. This is all my input. So first I'm going to put 220 and 284. Then I'm going to do 1184 and 1210, etc. Then I'm also going to type in these ones. And let me just show you what it looks like when it runs. So here's my driver. If I press play, got my heading up at the top. First thing it says, please enter a number. The first one was 220. Please enter a number, 284. If you notice, it prints out the proper factors all on one line with spaces in between, and that's how I want yours to print out too. I want it to be all on one line, not all down the page. And then I want you to print out the sum of the proper factors of the first number is whatever that sum is. So this is num1, this is sum1. The sum of the proper factors of the second number, so num2 and sum2, print those out. And then print a message saying 220 and 284 are amicable. Would I like to run it again? Sure. You're going to keep typing in all these numbers. So 1184, 1210. Those ones are also amicable because the sum of the first one equals the second number and the sum of the second one equals the first number. So they are amicable. Let's run it one more time, but this time how about I try one that's not? So I'll do 250 and 333. 250, 333. Still prints out the proper factors. The sum of the 250 factors is 218. Already I can tell they're not going to be amicable because that's not equal to 333. Doesn't work the other way either. But if either of those are wrong, we would print out not amicable. If that's the end of it, I can say 2 for no, and my program finishes. Okay? So that's what your program should look like when you're running it. As always, check the answers and the output in the black binder by the window to be sure that you've got everything correct. And if you want to look at what the answers look like while you're running the program, maybe take a picture of that. But your first task is to do that hierarchy chart, so go to work on that and call me over when you're ready for me to check or have a question. Good luck.